Good morning, everyone. Thank you very much for coming to today's plenary lecture. It's really wonderful that we have Linda Moy speaking to us today on the topic of ocean-safe imaging. Dr. Moy is Professor of Radiology at the New York University Grossman School of Medicine. She's also the editor of Radiology. And although I don't always like to say, oh, the first female this, the first female that, I think sometimes we just have to acknowledge it. She is the first woman editor of Radiology, and we're incredibly proud of her. But she's also a wonderful researcher. Her research focuses on diagnostic oncologic imaging, predominantly in breast care. She's a National Institute of Health-funded investigator researching multiparametric MRI and artificial intelligence. She collaborates with the New York University Center for Data Science to investigate deep learning for multitask learning across all modalities. But in addition, she's also passionate about sustainability and works with several societies on the topic of planetary health. It gives me huge pleasure to welcome to the stage Linda Moy. Linda, please.
Thank you, Andrea, for your kind introduction. Good morning, everyone. What a privilege it is to stand here with you in beautiful Vienna on this extraordinary stage at ECR 2025. This year's theme, Planet Radiology, is more than just a concept. It's a call to action. Our community is indeed a world of its own, but we are also part of something much greater. This planet we call home. Just as we devote ourselves to the care of our patients, we must bring that same dedication to the care of our world. By now, it's clear to all of us that action is no longer optional. It's essential. I hear this loud and clear at home from my two children, a 17-year-old boy and a 20-year-old girl. For them, saving the planet isn't just a concern, it's the concern. If you have teenagers, you know what I mean. Their passion, their urgency is contagious. And it should be. With my editorial team at Radiology, we've been publishing an annual sustainability issue for the past 3 years. The response has been overwhelmingly positive. We also publish multi-society papers on this topic. For example, this joint paper with the ESR. I'm proud to say this was just published on Tuesday and with representation from 12 radiologic societies. So it's clear that awareness is growing. But awareness isn't enough. We need action. Take a moment to look at this oyster displayed here on stage. This is more than a shell. It's a symbol, a reminder that life itself began in the ocean. Oysters are fragile yet resilient. They create something extraordinary. as a defense against intrusions. But more on that later. Here's a challenge for all of us. Can we, as radiologists, create something equally impactful? An industry that defends our planet as much as it heals its people. Let's start by examining how our work impacts the environment, particularly our oceans, and more importantly, what we can do to make a difference. So contrast media and its effect on the ocean is a growing concern. For all of us, contrast media is vital to our work, but its environmental footprint is undeniable. Since 1988, approximately 500 million doses of gadolinium-based contrast agents have been administered worldwide. Each year, we perform 50 million MRI scans using these agents. Wow, that is a lot of drops of gadolinium that we administer. A staggering amount of gadolinium drops entering our ecosystems. Here's the problem. Water treatment plants cannot filter out heavy metals like gadolinium, so it accumulates in aquatic ecosystems, disrupting delicate balances. Fish livers store gadolinium, triggering antioxidant enzyme production. Sea urchin larvae develop abnormally, and freshwater mussels suffer mitochondrial dysfunction. And the damage doesn't stop there. Traces of gadolinium have been detected in surface water, drinking water, and even beverages like soft drinks in Germany. This isn't a localized issue. It's a global challenge that demands our urgent attention. So what can we do as a community? Are there solutions that make a difference? There is good news. We can act. Small changes in our practices can lead to profound improvements. We have been using weight-based contrast dose for more than 20 years. We know that smaller individual bottles lead to waste. So, we can use larger bottles of contrast and multi-dose injectors. Switching from single-dose injectors to multi-dose contrast injectors can reduce contrast waste by 73% and plastic waste by 93%. This is actually a win-win situation. Doing so also results in annual savings of nearly $500,000 per year and a reduction of 41 seconds per scan. We can also use newer gadolinium contrast agents that have a higher T1 relaxivity. This makes the MRI scans appear brighter. These modern agents allow us to reduce the contrast dose in half, reducing gadolinium excretion by 50%. We can recycle residuals by establishing partnerships with recycling programs to manage unused contrast media and leftover residues so that they don't end up in our water systems. We can count on patient participation. The Green Water study in Italy showed how effective patient collaboration can be. Over 94% of patients in the study, which was presented 2 years ago at ECR 2023, were willing to stay an extra 30 minutes after their scans to enable urine collection, thus reducing gadolinium discharge into wastewater. Each of these steps brings us closer to a more sustainable future. Step by step, drop by drop, we can turn the tide on water contamination. Let's switch gears and talk about AI and technology and how we can use AI to innovate for sustainability. So artificial intelligence isn't just revolutionizing diagnostics, it's opening new doors for sustainability. By integrating deep learning algorithms, we can generate high-quality diagnostic images with reduced contrast dose or no contrast with synthetic post-contrast image, protecting both patients and ecosystems. AI is not only helping us use lower doses of gadolinium, it's also helping us scan faster. Here is an example of what we can do with increased enhancement, which is like using filters for photos on our phones. It makes the images appear sharper and faster to acquire for radiologists. But isn't it even a better solution to avoid gadolinium ending up in our oceans to use no contrast at all? We can do that with AI and non-contrast sequences, where we simulate the contrast. We can create synthetic or virtual post-contrast images, and voila! We have these perfect synthetic images where AI and computer post-processing did their magic. I do believe that the synthetic images are quite comparable to the images where contrast was administered. And innovation doesn't stop here. We're exploring other alternative imaging techniques that eliminate the need for contrast media entirely and even developing environmentally friendly contrast agents. So with contrast, the dye is going to areas of increased blood flow. That's what we mean with functional imaging. This is how we know how aggressive is the tumor or how bad the infection is. All of these techniques have been developed specifically to look at the metabolic activity in the body, and they are key to the future. But right now, these sequences take too long to image. So another way of reducing contrast would be to improve these more novel MR imaging sequences that are currently only used in the research setting because they are too time-consuming to perform in the clinic. With AI, we could really use some of these sequences and then, again, eliminate the need for gadolinium. Every drop saved matters. With contrast, gadolinium is the heavy metal that is bad for us because it doesn't get broken down in the environment. So we could use other elements such as manganese and iron. These new contrast agents are other alternatives to gadolinium. Every drop counts. So plastic waste, I think it's a shared responsibility. It's a big concern, the sheer volume of plastic waste generated by radiology, from single-use gloves to disposable syringes. Globally, 400 million tons of plastic waste are produced every year, but only 9% is recycled. Here's the hard truth. Even biodegradable plastics fail to decompose in the deep sea environments because the code prevents polymer breakdown. So, what can we do? Well, we can advocate for sustainable product designs with reduced packaging waste. We can partner with vendors to develop reusable imaging components and prioritize eco-friendly materials. We can use biodegradable gloves and other materials that degrade more efficiently in landfills. It's clear to me that even small changes can ripple out into significant impacts. Every drop counts. Water is another vital resource we rely on in radiology for cooling imaging equipment, for data centers, and for daily operations. Yet, water scarcity is one of the most pressing issues of our time. We can reduce our water consumption through efficient cooling systems. Sharing cooling infrastructure between multiple scanners can significantly reduce water usage. Recycling water. We can implement systems to reuse water wherever possible. We can also conduct water audits, evaluate how water is used, and identify opportunities for conservation. Water, like contrast media, is precious. Let's treat it that way. Every drop counts. I think we, as radiologists, need to rethink MRI and think about designing it for sustainability. So MRI technology represents the cutting edge of radiology, and now I believe it can lead the way in sustainability. Just imagine an MRI scanner built with eco-friendly materials, designed to last longer and consume less energy. Vendors can help us by including end-of-life plans for their equipment, ensuring that materials are recycled rather than discarded. Advances in MRI technology, such as low-field systems and improved coil designs, can also reduce energy consumption without compromising diagnostic quality. These low-field systems can also address global healthcare disparities. Let me tell you about this initiative led by Dr. Andrew Webb in pediatric patients with hydrocephalus in Uganda. There were 400,000 new pediatric hydrocephalus cases per year, 96% of which occur in developing countries. Dr. Webb and his team are using low-field MRI and AI to identify pockets of dangerous buildup of cerebral spinal fluid in the brain. The fluid can then be safely removed and allow for normal brain development. Low field strength MRI systems reduce energy consumption in production and use phases. But the benefits don't end here. These systems cost less, they have reduced footprints, and increased portability compared with the 1.5T and 3 Tesla MRI systems. So expanding clinical low field strength MRI can decrease energy consumption and improve global access to the technology, making it available in places where conventional MRI isn't usually accessible. Well, how's that for a sustainable approach? Bottom line, when we invest in sustainable MRI, we invest in the future of radiology and the planet. Every drop counts. I believe collaboration is key. None of this will happen without collaboration. So radiologists, manufacturers, hospitals, policymakers, we all have a role to play. We can draw inspiration from initiatives like the Oyster Reef Restoration Program carried out by the U.S. National Oceanic and Atmospheric Administration, NOAA. I know, oysters again, but I told you we would circle back to that during this talk. Let me tell you another interesting fact about oysters. Oyster reefs create important habitats for hundreds of sea creatures. But oyster populations are at historic lows due to erosion from overdevelopment and pollution. A few years ago, the NOAA identified oyster reef restoration as a conservation priority. To make sure they would successfully protect these fragile ecosystems, they included every stakeholder in the project: industry, academia, and government. They created working groups, grants, and set goals and progress measurements to increase visibility and engagement from their partners. So the key is that with clear goals, measurable progress, and accountability, radiology can achieve the same kind of transformative impact. I wish to conclude that standing here today, I feel hopeful. Radiology has always been a field of transformation, driven by innovation, solving problems, saving lives. Now, it's time to extend that transformation to the planet itself. Back to our stage now. The oyster teaches us something profound. When faced with adversity, it creates a pearl, a defense mechanism turned into beauty. Let me show you. Wow, what a stunning metaphor for what we can do. We too have the power to turn challenges into opportunities. Together, we can address plastic waste, water scarcity, and contrast media contamination. We can heal the planet as we heal our patients. Because, like the oyster, every action counts. Every drop counts. Together, we can protect our oceans, our planet, and our future.
Thank you so much. That was absolutely wonderful.
Thank you.
I'm going to give you this. I'm going to look at the camera over there. Thank you so much for that wonderful lecture about ocean-safe imaging. I'm not sure where the camera is. There they are. There they are. Thank you so much. And we have a special gift as well for Linda, which is coming in a moment. Okay?
Great,
Thank you. One moment, please.
Okay.
One moment, please. We have
Sure.
something very special. Many congratulations on your presentation. We have an oyster with a small pile.
It's a beautiful oyster rouge. Thank you.
Thank you so
Thank
much.
you.
Thank you. Many congratulations.
Thank you.
And that concludes the plenary session for today. Thank you very much for attending.
Thank you.
Okay?
Yes,
Well
thank
done.
you.
It was great.